So friends, we are left off halfway because the electricity had gone. Apologize for that. It's a very rare situation which happens here. So let us continue our problem from last. So we are solving problem for vector resolution. Okay, what is given here? A box slides down a distance d is equal to 6√3 meters along a surface oriented at angle theta is equal to 30 degrees to horizontal. Remember, you have to be very careful whether it's horizontal is given or vertical is given. Sometimes vertical is given, so you have to calculate the horizontal and resolve, or you can use the vertical, but be very careful about angle being respect to what. Here it is respect to horizontal. So what it is asking, what is the question? How much has the box moved in A horizontal and B vertical? So try to solve it before looking into the solution. Pause and try to solve it. So what we are given here? We are given an inclined plane where an object is kept here, and the distance of the object is given as d, and d is given as 6√3 meters, right? And this angle theta is equal to 30 degrees. Theta is equal to 30 degrees. So now what is asking? It is asking how much the box has slide down horizontally and vertically. That means when the box is sliding down, it is traversing. When it is traversing down, sliding down, it is moving down in the y, right? And it is moving left in the x also. This is how you are supposed to resolve it. So how to resolve it? We have this block moving in this direction, and this distance is given as d. So the movement along y and then movement along x, and this is theta. So how do we resolve this? Now x can be written as d cos theta, and d cos theta is 6√3, and cos of 30 will be √3 by 2. So this will cancel. 3 3s are 9. So you'll get 9 meters along x, that means horizontal. Now along y what will happen? It will be d sin theta will become equal to 6√3 into sine of 30 will be half. So this will be 3√3 meters vertically. These are your answers, right? So vector is very important. We actually solving one-dimensional motion problems here, right? So let us move ahead to the next problem. We'll wipe out this. Next problem, I guess the 7th problem. A wheel of radius is equal to 45 centimeter rolls on a horizontal floor at time t1. The dot P is at point of contact. POC is point of contact between wheel and floor. Okay. At a later time, what happens? At a later time, T2, the wheel has rolled prove 1/2 of a revolution. What has happened? Basically, what is given? Let us solve it. You pause it, try to solve it yourself. We are solving rotation problems in vectors. Can you imagine this? Just by knowing vectors, you can solve so many problems. Okay, let us see this. A wheel of a rod of radius. This is the radius. This radius is 45. R is given as 45 of the wheel. It's rotating it rolls on a horizontal floor. This is a horizontal floor. At time t, the dot P is in contact, a point of contact between floor and the wheel. So this is point P, and this is the wheel having radius R. This is the point of contact initially. Then what happened? The wheel has rotated 1/2 the revolution. 1/2 the revolution means it has rotated to the topmost point. So the wheel has moved to the topmost point. The point P has moved to the topmost point. Right? So what is the question asked here? It is asking what is the magnitude of displacement of P. Wow, nice question. Nice question, right? So how do we solve it? How do we solve it? So basically this point has got displaced to this point. So that means this point P has moved along x-axis and it has also moved along y-axis. And this is the final displacement from here to here. This is the displacement. Right? So it has moved x distance and it has moved y also. From here to here, we'll say the distance is d, and from here to here this is y. So what is the distance moved horizontally? Distance moved in horizontal is given by d, right? But how much it has moved? How much it has moved? It has moved from here half revolution. It has moved half revolution. Full revolution is 2 pi r. If the point P would have moved full revolution, then it would be 2 pi r. So this distance d traveled, because it has actually traversed this much distance, right? Because it has moved only this much distance, it has traveled half the circle. So half the circle will be what? Full circle 2 pi r divided by 2. This will be half the circle. This will be pi r. So it will be equal to r is how much? 45. So 45 pi. D will be 45 pi. What will be the vertical direction? For vertical direction, what is the moment? Vertical. How much it has moved vertical? Basically this point P, vertically it has moved straight up. Vertically it has moved straight up, and this is r and this is also r. So vertical movement is y is equal to 2r, which is nothing but 90 centimeter. So what is the resultant? The resultant will be, this is the right angle. So this will be resultant of d square plus y square. So this will be how much? Square root of 90 ka square plus 45 pi the whole square. So we can try and solve this. We'll get the answer. I think the answer is about 167.33 centimeters. Okay, this is the answer you're supposed to get. So hope you're enjoying the problems. So let us take one more problem. After 7, we'll solve one more problem, 8th problem. This is the beauty of vectors. You can solve without even learning force, even without learning rotation. You can solve problems related to motion and rotation. So let us solve the 8th problem. Weight mg of a block is force acting downward, right, towards center of earth. A block of mass is equal to 1 kg is placed on inclined plane. Okay, this is the figure shown. This is the figure shown. This is the block, and this is x. This is shown as y. This is the block. This is a 1 kg block, and this angle is shown as 37 degrees. So remember, for 37 degrees, what are the sides? We remember for 37 degrees, if this is 37, then this is 3, and this will be 4, this will be 5, and this will be 53. Okay, these are the sides of the triangle here. Okay. What we are asked? We are asked to find x and y component of the weight. We are asked to find x and y component of the weight. So we know that we'll try to solve it now. In this much space, we'll try to solve it. So this is the block being given. This is the block lying like this on the inclined plane. So the weight of the block will act downwards. This will be mg. So now this angle is 37 degrees. So now for this weight mg, what is asking? To find the x and y component of the weight, right? This is the weight. This is the weight. Weight is equal to mg. It is trying to we need to find the x and the y component of the weight. So if this is x-axis, then the x component of the weight will be this way. Let us call it wx, and the y component of the weight will be this way. We'll call it wy. So now we need to know the angle. We need to know the angle. This is 37. This is 90 degrees. So if this is 90 degrees, then this will be 53 degrees, right? So what will be the components now? So we can write wx is equal to, wx is the adjacent side of this angle 53. So we can write wx is equal to weight. This is w weight, w cos 53, right? And what is w? W is given as 1 kilo, 1 kg into cos of 53. What is cos of 53? Cos of 53 is 3 by 5. Cos of 53 is 3 by 5, right? I have taken weight as 1 kilo, but actually it is 1 multiplied by gravity, right? It will be 10 Newton. So it is 10. Okay. So we cancel this. This will be 2. It will be 6 Newton. So W along Y will be W, which is the Y component, this way. So it's the opposite side, no? If I draw this component here, it will be the opposite side of this angle of 53. So W opposite means it will be sine of 53. So W is 10 into sine of 53 is 4 by 5. So this will be 2, this will be 8 Newton. right? Fair enough. So here we don't see we have not taken into consideration the direction by as a matter of fact, right? Actually, left side moment should be taken as negative, right? And downside moment should be taken as negative as well, right? So y component should have been minus 8 Newton. It should have been minus 8 Newton, right? And this side also should have been minus 6 Newton. So we'll see this further in more detail in the chapter where we'll consider motion of objects. So let us take some more problems. We'll clear this. What problems can we take next? We'll take a theoretical problem. If the resultant of several vectors is 0, then point A is given as the x component of resultant vector, what is this? X component of resultant vector must be 0. Point B, the y component of resultant vector must be 0. C is given as the z component of resultant vector is 0. And D is given as none of the above. Try to think. What is given? The resultant of several vectors is 0. Right? The resultant of several vectors is 0. That means it is actually stating that the resultant is actually 0. So that means all Rx equal to Ry will become equal to Rz will become 0. So these are the correct answers. Okay. Hope this is clear enough. So with this we have solved multiple problems for resolution of vectors. So if you have enjoyed this video, if you have enjoyed solving the problems with me, please like, share and subscribe as well to the channel so that you can stay tuned to multiple other concepts of basic maths as well as the other chapters of physics which we are going to cover in subsequent videos. So thank you until then.